So working with complex fractions, again, we want to simplify this complex fraction expression. And method 2 is my preferred method most of the time. It just shortcuts a little bit the other one. If you feel comfortable about it, you recognize how denominators are working. And so let me just rewrite the problem down here. And what we do in this method is we just identify what is the common denominator between the bottom and between the top. Well, the top doesn't have one, or you could think it's a 1, right? So 1 and x, so the common denominator is x. So I'm going to multiply this entire expression, the top and the bottom, by x. Now I want to show you, in fact, let me do this just to really show what I'm doing. So the top, I could think of it as being 5 over 1. The bottom is 2 over x minus 7, right? All I did was rewrite the top as a fraction as well. So common denominator, 1 and x is going to be an x. So I'm going to multiply this entire thing by x over x. And to even show that maybe easier to see, I'm going to do x over 1 times x over 1, just to kind of help see what happens when we multiply fractions. So 5 times x is 5x. Of course, 1 over 1 is just or 1 times 1 is just a 1. I'll go ahead and write it here. It's going to disappear. I could just write 5x on the top, but just to show the fraction, I'll do 5x over 1. On the bottom, let's see what happens. So I multiply x through here, so I would get 2x over x minus 7x over 1. Now that maybe doesn't look like we simplified anything, but watch what happens. So the top, 5x over 1, that's just 5x. On the bottom, well, what's 2x divided by x? My x's go away. So I just get 2. And 7x over 1, of course, is just 7x. And just like that, I'm done. So that's what I mean. It's a little bit of a shortcut. It eliminates the combining. It just wipes out your denominators in one nice step. So that's the method I really like to use. So we're going to try some other ones, go look at some more examples together.